Hello everyone, myself Nazneen Zehra from Department of Wildlife Sciences. If I can connect you from the last lecture, so we had a detailed talk about predator and prey interaction and its outcome in the form of functional and numerical responses. Today I'm going to talk about foraging. So let's see what is foraging. In simple terms, foraging is a searching by the animals for wild food resources. It affects an animal's fitness because it plays an important role in an animal's ability to survive and reproduce. It results in animals' movement, which animals make in search of food resources. This movement ends when they encounter with the food resources of their choice. Sometimes this movement also occurs along with the aggressive behavior when any intruder enters in the animal's territory, and this movement ends when that intruder leaves the territory of the given animal species. I'll go for a foraging of herbivores. Animals forage for nutritional requirements or dietary diversity. Although this is an older and simpler approach, which suggests that animals go for foraging to fulfill their dietary requirements, they avoid overeating on toxic plants and other secondary components. Optimal foraging occurs in attempting energy gain per unit of time might maximize the resource an animal has for survival and successful reproduction. If you guys want to go in great detail, so there is a document Khan 1994 on food habits of ungulates in Gir ecosystem and Pike et al 1977 for optimal foraging. These documents will give you immense detail about foraging and optimal foraging, and both documents have been uploaded on the Google Classroom as well as on the departmental web page. Foraging zones are those patches where animals eventually reach in search of food and shelter, and on the basis of availability of food resources, they establish their home ranges around. But every foraging zone has certain constraints in form of biotic and abiotic factors which control the environmental conditions of the given zone and local food resource availability for the animal, such as the abiotic conditions, temperature, rainfall. All these factors they control food resource availability. Because animals of different age and sex they eat upon these resources, even morphology and physiological conditions also help them out to eat upon the given resource availability, which makes their dietary composition that ultimately govern to the fitness of the animal. Okay, I'll make it easy for you as we have a different group of animal taxons. So few species are well adapted to live in aquatic ecosystems. So other species are well adapted to live on terrestrial ecosystems. These ecosystems or species survival resources are being controlled by the environmental conditions, which is being controlled by abiotic and biotic factors. If talk about the thermal regime, so few species can live and thrive well in the higher altitude like snow leopard, clouded leopard, Thar and Kashmiri stag. So in other hand, elephants and rhinos, they have their restricted ranges in plain region. Few species like camel, antelope and desert fox, they can live and thrive well in higher thermal regimes. So other species like African lion, giraffe, zebra, cheetah, they are well adapted to live and survive in conditions of savanna ecosystems. So environmental features including the thermal regime and landscape features play a crucial role for survival of these given taxons of animals, where competition and behavior play an important role for survival of population of these given species, where they use different strategies for resource utilization either in the form of food or shelter. So till yet I have talked about large animals, but what about small mammals like rodents, shrews, mice and rats? These species become active during midwinter and they don't undergo heterothermy, which is a process of self-regulating their body temperature. So thermal regime is crucial for knowing the energy budget of these species. In case of dry deciduous conditions, these species live in tunnels under a layer of soil and litters, which provide comparatively warm thermal regime to these species. If it is additionally covered by the snow, that will provide additional insulation to these species. So thermal regime play a crucial role if talk about the birds migration. So we all know about the factors which trigger migration in birds. The food scarcity due to special temporal changes where birds they migrate towards patches of rich resources. For the herbivore species, the grasslands and forest ecosystems are the foraging zones. Even large carnivores also follow to herbivore species and get in their foraging zones. On the canvas, we have four pictures. The first is of sambar, which is chewing on a bark of a tree. Second one is of cheetal herd, is on grazing. Third picture is again of a cheetal herd but on browse, and fourth one is of giant male nilgai in a scrubland. So these pictures are showing clear differences in food choice of herbivore species or say ungulate species in a single ecosystem. So to fulfill their nutritional requirements, animals opt to different food items such as high quality food types support peak reproductive outputs. Staple food types provide the bulk of the diet for much of the year. Reserve food types animals eat when staple food depletes, and buffer food types animals consume during critical periods, slowing the rate of starvation. There are some other categories like bridging food which serve for that period when little else has remained to eat. And one more category is of high quality food which can be eaten at slow rate, but functionally it has been categorized as distinct category. So all these food types all together contribute towards enhanced diet quality, but all these food types should be complemented with some food items which can be rapidly eaten by the animals to at least fulfill their daily requirements. Food resources can be subdivided among functional categories in terms of their dietary contributions to eaters in different seasons. See, these herbivore species they face a vast contrast of seasonal cycle, special temporal variations, and they shift their diet according to prevailing situations. As during summer or wet season there is a vast superabundance of nutritious forage which depletes during winter season, although this season have some fruiting trees to support to the diet of these herbivore species. But let's see how these species respond to the seasonal changes in an adaptive way, and these consumers depend on heterogeneity of the plant species to cope up with the situation. Cheetal, it is a mixed feeder, but primarily it is a grazer, graze more during monsoon season, and secondly it is a browser and browse more during winter season. Following certain conditions like seasonal changes, food availability and its quality, it browses on some shrub species like Acacia nilotica, Caparis sapiaria, Halicterus isora. Some species of Ziziphus like Mauritiana and Numelaria are favorite to cheetal. The grasses on which it feeds upon are Apluta mutica, Arthropogon contortus, Themeda, quadrivallis. It also feeds upon a climber species like Combriatum roxburghi. The shift in the diet of cheetah triggers cause of spatiotemporal changes per se in the monsoon and post-monsoon. There is a vast availability of grasses which grow on and create an optimum conditions for the cheetal, but during winter season grasses disappear from the scene and they shift their diet towards the browsing material and compensate their diet by feeding upon some browsing species. It is suggested that increase in browsing content in the diet of cheetal that coincide with the fruiting trees as well as with the fawning season in the cheetal. If the content of grasses has been found more in the diet of cheetal that coincide with the dry grass availability with less nutritious content. Sambar, it is a mixed feeder but primarily a browser. It feeds upon some species like Capariceparia, Amblica officinalis, Halictidus isora, Xeromphis spinosa, Tectona grandis, and Ricea tinctoria. Although sambar, it feed upon much more on bark of trees rather than feeding upon shoots and leaves during winter season and summer season, while during monsoon season they feed upon grasses on the basis of its availability. Nilgai is a mixed feeder. It can graze as well as it can browse in varying proportions throughout the year, but dominantly it is a browser. The preferable plant species of Nilgai are Acacia nilotica, Acacia leucofolia, Butemonosperma, and Ziziphus mauritiana. The diet width of nilgai is broader in comparison of sambar and cheetal, as it can survive in low quality habitat or it can feed upon variety of plant species even with low nutritional content. It can survive even in a suboptimal habitat as per its large size and low requirement of energy per unit of its body surface area. So if you have observed that cheetal, sambar and nilgai, they are using similar plant items for feeding purpose, and these three species are sympatric species in a single ecosystem. These species using same or common plant items by using resource partitioning mechanism where they eat upon different products of a same plant item, as we have observed that nilgai can eat upon any product of the plant from shoot, pods, leaves or twigs, whereas sambar they probably eat upon bark and cheetal they feed upon leaves. So it is making their coexistence successful by reducing level of competition. Types of foraging, we have two types of foraging: group foraging and solitary foraging. So solitary foraging I have discussed in detail earlier. Today I'll go for group foraging. Here you can see three pictures on the canvas. In the first picture, a cheetal herd is looking alert by some danger in the surrounding, while in the second picture the group is running as they have sensed any predator in close proximity, which has been conveyed by its posture by keeping the tails up. As per the approach of group foraging, where all individuals play an equal role in the group foraging, from searching of the resource patch to find it and to consume it. So success of finding a resource patch doesn't go to foraging behavior of a single individual. It goes to the foraging behavior of all individuals in a group at a given ecosystem. As this approach has certain costs and benefits in group foraging, so here are we have certain costs and benefits for group foraging, which are like find better feeding sites and get more time to feed when individuals come in groups to foraging sites. Individuals are being kept informed about local food availability, as there are many individuals or many heads to search in a local ground for local food resource availability. They reduce risk of becoming a prey at individual level but increase detection by the predators. They dilute individuals' risk and can confuse predator too. As there is also a very interesting set of pictures on the canvas. In the first picture, one individual lion has taken initiative to hunting down a buffalo which is larger in size than the individual lion. When the second picture, other individuals have encircled the buffalo as it is bigger in size than lion size. To just achieve success of hunting down this bigger size prey species, all individuals have cooperated in the hunting event. In the third picture, all individuals are eating on their share, but as per its condition of cost and benefits, it brings greater rewards and reduction of predation threat. Competition to use resources, as you can see in the third picture, that all individuals are eating upon, but there may be chance of competition while one may eat more in comparison of others. Group size, there should be optimal group size. If a group is larger, so one individual is not enough to support the diet of all individuals. Species and sex. In case of lions or social animals, the females take initiative to go for hunting events, and they don't go so far from their territory, or if it is a female mother or it has cubs in the territory. So they take this initiative in the close proximity of the cub site and then provide opportunity to other individuals of their pride. So I'll stop this lecture here. Till then, bye bye.